is the segment of the program where I get to hand over the moderation to my colleague Helen, who will be hosting the second session on policies that drive the market. So Helen, this is officially passing the baton, and yeah, go ahead.
Got it. Thank you. Thank you, Bronwyn. This is my pleasure. In fact, I was so happy that Bronwyn asked me to do this because code standards policy is something that I get pretty passionate about, representing FTI, Facade Tectonics Institute. As I mentioned, I'm involved in the IECC 2024 and chairing the FTI Advocacy Committee, trying to move the needle on our building codes. So I'm excited to welcome our panelists today. We have Steve Salkowitz, who almost goes without introduction, very famous and driven the development of Therm and the suite of LBNL simulation, window simulation products. So he's up first, and he will be followed by Bronwyn and Peter Dushensky from Glass Curtain. So without further ado, I will hand over to Steve. I believe Steve's going first. And if you want to look at details of their bios, they're on the website at the link for the symposium. So Steve, take it away.
Thanks for the intro. It's been great the last 2 or 3 hours here, sort of catching up on lots of other bits and pieces. I'm going to try to move the discussion a step or two forward, maybe sideways at the same time as well, and focus on this theme of how do we drive the industry, how do we move things forward, getting better windows out there. And the theme, the kind of high-level theme of my little piece here is that if we want better windows for passive buildings, the best way to do it is probably to get better windows for all buildings. And this has to do with the underlying drivers and how companies, or why and how companies offer products, their perceptions of risk, of opportunity, and so on. So I'm going to start at a high level, some big picture stuff, then get down into some of the weeds in the way that some of the earlier presentations have, and then end up on some broader kinds of issues at the end. So let's see if I can get this moving here. Okay, so at the high level, you all know this. An underlying really important driver for thinking about better windows is energy and then carbon. And I'll repeat some comments made earlier that we've been focusing a lot on operating carbon. We need to be paying more attention to embodied carbon as well. There's a whole other long list of building related solutions. And I want to repeat again a theme I heard this morning, that although we're talking about windows, we're really talking about windows in the context of buildings. And it's important to understand all those kinds of relationships, a few of which I've just sort of sketched here. So if we just jump into the Windows world for a moment, my focus historically, so I was at the lab for 40 years, at Lawrence Berkeley Lab for 40 years, and started right after the first energy crisis, or the energy crisis in the mid 70s. Energy was the key issue then. Energy still is an issue now, the operating and embodied energy and carbon here. On the right-hand side, though, anything we're doing to design better windows, we obviously have to pay attention to all of the issues on the right. A few of these were touched upon in the earlier presentations. And then I want to jump back to the left to these items in red that were also mentioned this morning, and I think are becoming more important, more critically important. And they're also an opportunity in terms of how we can leverage the power of better windows in justifying the expense in some cases of better windows. I'm not going to unfortunately have time to talk much about them, but I want to flag them and make sure that they're sort of on everyone's agenda here. Now, the big picture, again, this comment was made starting with Ken this morning, that we are talking about window and glazing in the context of at least an integrated facade system, and of course the integrated building. If we had a lot of time, we could spend time talking about all the kinds of issues here, but of course we don't have that time, so I'm going to focus on the really one of the two in red here, the highly insulating glazing. But I just want to sort of start with a reminder that this is a piece of a much bigger problem. This came up at the end of the last session as well, in terms of not losing this sort of perspective of the forest for the trees here. So drilling down a bit into the role that windows play, if you look at the building sector in the U.S., windows impact mostly heating and cooling with some ventilation and lighting. That impact end uses that make up about 43% of all the building use. And if you look at the pragmatic part of what they actually impact, because they don't obviously do everything, it's about 10% of all building energy use, or about $40 billion a year. So there's a target there to be saved. If we drill down a bit more and look at a few separate issues here, one of the points I want to highlight, I'll come back to later, is that this is not just a new building issue, this is an existing building issue as well. So we have 48 million homes in the US, about 41% of all the houses out there, that are still single glazed. And there's this market out there of 1.4 billion windows. We're replacing them at the rate here of, well, the 29 million retrofit a year. Some of that is replacement, some of that is, adding a room to a house. But we're replacing at a pretty slow rate. We aren't going to make a lot of progress in taking care of all those single pane windows unless we do something special about it. But the problem isn't just older buildings. The problem is new buildings as well. If you look at the new IECC code for 2021 on the upper left here, you see ceilings that are 60, you see walls that are 20, and you see windows down there in the R3 range. What this means is if you look at the overall UA term in a typical house that would meet code, windows represent about 8% of the area of the envelope, but about 47% of the heat loss. So that's both a problem and an opportunity. Now, my perspective on this and the work I've been doing for 40 years has been that we can do much better. And in fact, I go out to the extreme and say that we're smart enough to design window and facade systems that will do better than an insulated opaque wall. And not only that, but we can do it in almost any climate and pretty much almost any glass area. Now, that's the theoretical limit, but the caution's on the right. It's not going to be easy to do. The products may or may not be out there at the moment. You still have to build it and operate it effectively, and it's probably going to cost more. But at least we think it's technically possible to do that. And at least in terms of trying to frame the discussion, it starts to give you some feeling or some sense about what the possibilities might be. Now, one way of translating that into dollars and cents is to say, let's take the commercial sector for a moment here. If you were to hypothetically put the best conceivable windows in every commercial building in the US, you could change them from their current roughly $20 billion a year cost, which is this top line, the current stock, to a net savings of, you can play games here, 10 to 15 billion if you take advantage of daylight and PV in the windows as well. But the key issues in the middle here are basically reducing the heat loss, the highly insulating windows, and because of the role of cooling in these buildings, you also want to control the cooling load. So you can get from this 20 billion cost to a $15 billion savings if we do all the right things. Now, this is going to be obviously sensitive to building type, to building size, to climate. And just in terms of thinking about climate here, this zero energy facade or zero net energy approach obviously is going to be different in a heating climate or a cooling climate. And for purposes of the talk now, I'm going to focus more on the heating side, but I don't want to lose track of the cooling side. These are increasingly important also because a lot of the construction in the US is in southern climates where cooling is more important. So let's take a look, excuse me, let's take a look at the window market in more detail. Good news, bad news curve here. This is a plot of the sales of US windows. This is residential windows from the 70s, early 70s to about now. So you see the gray curve there, single glazing. After the advent of that first energy crisis in the 70s, single glazing dropped, double glazing went up. That was sort of good news at the time, but we can do much better than an R2 double glazing. And the orange curve there are low E double. And this, in fact, I started at the lab in the mid 70s, and the first project we worked on was to try to get low E out of the laboratory into the marketplace. And, I think the track record here looks pretty good. We've gone from 0 to about 90% of the market. But these windows are still only about in the range of R3. If you look at the bottom on the right there, the green line is triples. It's a couple % of market share, and it hasn't changed a lot in a long time. So we have a real excuse me, we have a real challenge here. The other thing on the good news, bad news part is the fact that we're up to 90% on double OE is good. The fact that it took 30 to 40 years, if we have that kind of track record going to triple, we're going to be in trouble because we can't wait. So what do we know about triple glazed windows in homes today? Most passive buildings, passive houses, I think probably have them. There's a collection of what we'll call zero energy or zero energy ready homes in the US. There was a survey done recently of a bunch of those builders. They found about 2/3 of those builders were using triple glazing. So passive house uses triple, some of the zero energy homes use triple, that's great. If you add them up, and I've tried to guesstimate some of these numbers, I think if you look at all the buildings that fall in those two categories, you end up with a couple 100,000 windows per year in a national market of 15 million. So if you're a company making windows and you say, I want to make windows for the market, this isn't yet at the point where it's going to attract a lot of your attention. That chicken and egg is partly why we see such a small, excuse me, a small number of triples in the market today. Now, take a slightly closer look at where windows are sold. These are the Energy Star criteria for climates, which map other code requirements also. You see that most of the windows are in the north and north central. Notice that the retrofit market is bigger, which makes some sense. These are probably older cities with older homes than, for example, in the south. And I'm starting to flag Energy Star here because my theme is going to be that Energy Star has some traction in the marketplace, and we want to try and build on that traction. The current Energy Star in the northern part of the US is a 0.27 window, which is easily obtained by double. That's partly why you see the dominance of those double OE. But this question I ask here, what if Energy Star required triple? What kind of a difference might that make? So this is the sort of theme for the major middle part of the talk here, is that Energy Star has a lot of traction in the US. It's a voluntary program, but it captures 80 to 90% of all sales. And if we could move that program to require basically triples, at least in the northern half of the country, we would reframe the way that window companies look at the market and perhaps get them to spend a lot more time and energy offering the products that in principle we know they can make now, but they don't make in volume. There's some organizations as Partnership for Advanced Windows and the utility incentive programs that I'll come back to later that are trying to leverage this as well. And I'm going to come back with a little more detail on Energy Star in a minute as well. Before I get into that, though, I also want to repeat comments that were made earlier today that although I'm going to drill down mostly in the glazing portion of this, the glazing is only a piece of the overall window curtain wall framing, and those in turn are only pieces of the bigger wall integration, thermal bridging. You've heard a lot about that this morning, so I'm going to focus on a piece of the problem, not the entire problem. If we go back to the manufacturer side, though, although in principle it's straightforward to make a highly insulating triple glazed window, if you look at it from the manufacturer's point of view, there's a lot of moving parts here. There's a lot of pieces and parts that you have to decide on. Helen went through a lot of the detail just on some of the spacers and the sealants. And there are those kinds of issues that exist across the entire portfolio of elements of the window here. In the upper portion are glass and coatings, on the left are spacers and sealants, and the right are sash and frame. So you get all of this stuff on the top part that goes into the IGU, and that goes into the frame, sash and frame, and you get your window. But there's an awful lot of work that goes on behind the window in terms of all of the details. And as you heard this morning, those details really do matter. Now, the other side of the coin is you have to be able to make this and make it cost effectively and at scale. The good news here, at least on the IGU side as well as the Windows side, is there's a lot of automation going on now in the marketplace. These are lines that are like 100 feet long that take raw glass in the front end or coated glass in the front end and end up with a fully fabricated IGU of any size and shape with gas filling and all that. These are on the market now from a lot of different companies. They make on the order of 1,000 units a day. So if you think about the capacity and the market needs, you know, if you have a tiny market, if you're only making 30 or 40 windows a day in a specialty market, you aren't going to invest in a machine like this. So getting volume up, getting the market to see that volume and understand it and build for it is critically important. Now, we want to try to get a sense of what double and triples can do in the market. I want to talk about this transition from double to triple. The NFRC product database is a good resource. This has been mentioned earlier today a couple times. This lists all the products that are NFRC certified. I'm going to talk now about this new Energy Star. Energy Star version 7 was proposed now, and there's a new draft out. It's supposed to be, assuming the draft goes through as planned, it might be effective middle of next year, middle of 2023. But you need time to plan for this anyway. The numbers you see on the right there, in the northern zone, it would require a U value of about 0.22. There are some trade-offs here. You can do a solar heat gain trade-off, as they've done in the past, that bring it up to 0.25 or 0.26. But the primary target here is going to be this 0.22. If you look at this left plot, this is one type of window. It's a vinyl vertical slider, which represents a large fraction of the existing market share, showing the U factor of the windows in the bottom and the numbers of product lines here. So if you look at the blue shapes there, those are double glazed units, and you see they peak around the 0.25 to 0.3 U value range in the middle. That's where the current Energy Star is. If you look at the purple lines, those are triples. And if we want U values with windows down in the 0.15 to 0.24 range, with that red bar on the left there, really the only way to do that is triples, or our triples, except there's a little bit of overlap there with doubles. But notice that if you only make a triple and you don't pay attention to it, note those purple bars go all the way to the right to windows with U values of 0.4. So simply having 3 pieces of glass packaged together in a window is no guarantee that you're going to end up with a product that meets the requirements here. So just going back for a second on the glass details, the glass on the left here, single, double, triple, and even I threw in a quad for good luck. This is what's on the market now with the kind of with the U value ranges I just showed below. On the upper right are some call it emerging or future products, vacuum insulating glazing, which you may have heard about. There are a few products in the market now, more coming. These have very good insulating values. Not yet really available at scale and on the expensive side, but maybe coming. Aerogel is some R&D that's still ongoing. And this is one in the middle in red, which has this double glazed unit, but with a single piece of a single thin piece of glass in the center. I'm going to come back to that in a minute, because that's a strategy or an approach that we think might make some sense for companies who currently make doubles, don't want to retool sash and frames to fit triples, but want to be able to meet those 0.2 U value requirements. And I'm in the lower right here, I'm reminding you that the sash and frame make a difference, even though I'm focusing here on the U value. I'm sorry, on the glazing. And again, this issue came up extensively this morning, the NFRC standard size versus the way the Passive House deals with all of this. Just as a reminder, if you have a fixed window with the NFRC standard size, 70% is roughly center of glass, and the other is edge of glass and frame. If you have an operable window, it's even less. So I'm going to talk now in a few slides about glass properties and window properties, and making the distinction here, because the glass properties can be easily brought down to the numbers of 0.2 or below, but the sash and frame need to follow through as well. So here's a plot of window U values on the bottom axis here, from about 0.19 up to 0.27, and the center of glass values needed to achieve them. So this bar in the center, the colored bar in the center, that's my new Energy Star 0.22 window U value target. And you can see here that roughly speaking, you need a glass package with a U value, a U factor of about 0.17 to 0.19 in order to get to 0.22. The bars there show you the extremes, and they can go much higher and much lower, but the majority of windows fall into this middle range. Not surprisingly, as you try to get the window U value lower, you need a glass package that has a lower U value too. So now I'm going to show you 2 slides that are a bit complicated, but I'm going to get into this issue of the width of the IGU. And I'm going to show you 2 different slides, one with a 3/4 inch IGU and the other with a 1 1/4 inch IGU. Something like 70% of all the windows sold in the US now have a 3/4 inch IGU. That's not surprising, because that's where the optimum is for double glazing in terms of the air fill or argon fill. This came up this morning in terms of the differences between US and Europe in terms of temperatures and all that. I'm not going to go back and rehash that. But in the US, with a 1/2 inch air gap as being optimal for argon or air. That's why you have a lot of these 3/4 inch IGUs. So let's take a look at the 3/4 inch IGU. I've got 3 sets of packages here. I'm looking at, on the left, double glazing, in the middle, double glazing with a surface 4 low E, and on the right with triple glazing. My goal is to get a 0.22, and I threw in an extra one here, 0.2 U value. So those are the horizontal bands. Those are the window properties at 0.22 and 0.20. And so if we start at the left, you can see that there's no way to get a normal double pane low E down into the range that would give me a window with a 0.22. If I add a full surface low E in the middle there, I can just about get to the top of the 0.22 range, but not really into it. And on the right, you see with triples, I can do it. So this is good news now, right? We can get a 0.22 or 0.2 U value window in a 3/4 inch IGU. But first of all, not all of them meet the requirement. The 6 different options there are glass packages. The one on the right are 3 pieces of 4mm glass. That would be a larger window, maybe on the commercial side. And the one on the left is a 2mm, 1.6 and 2. So those are residential sizes with a thinner piece in the center. And the reason you're seeing better performance as you get thinner glass is because you're getting more of an airspace, or in this case, a gas space. And then the 2 different gases, argon and krypton. Argon is the one in standard use now, but not as good as krypton in a thinner gap. So you see that going from argon to krypton gains you a lot when the air gaps are thinner, as you would expect here. That's great. The problem is krypton is much more expensive than argon. So it's not as easy to do. Now, the good news in all this is that if you're not making a 3/4 inch IGU, but a wider one, here's my 1 1/4 inch IGU. Notice how the right-hand side has changed now. Notice essentially any triple glaze package gets you down to the 0.20 range. And it doesn't really matter if you use argon or krypton. So the reason I spent a few minutes on all this is that if you're making windows now, and you make a window with a 3/4 inch IGU, you have some tough choices to make about how you would get to 0.222 in terms of the options I showed you before. If you're making a window that has a wider gap now, the sash and frame already accommodate a 1 1/4 inch IGU, you have lots of options and it's much easier. So the one thing that we worked on to try to help those folks that are making the 3/4 inch IGU is to be able to achieve the 0.22 value, the 0.2 value, without changing sash and frame. In the long run, you say, well, they should change sash and frame because the world evolves, and maybe they will. In the short term, though, if you make windows and you have to think about investments, you'd perhaps like other options. So the concept here is to drop a piece of very thin glass into the center of a double glazed IGU, this 3/4 inch IGU. Add either argon or krypton, depending on what you're trying to achieve, and look at what kind of values you get. If we look at this in more detail, this is what we're doing. This is the standard 3/4 inch double IGU on the left, and I can put a 1.6mm piece of glass in the middle. That's commonly available from every glass maker in the US, or I can put a 0.7 or 1mm glass in the right there. And notice in the center one, I'm using 2 spacers, and you have all the issues with sealants and spacers that Helen and others talked about this morning. But the other thing you could do, especially with this thin piece of glass, is just essentially hold it in the center of a single spacer, keep it from bouncing around, but not sealing it. That pressure equalizes the 2 gas spaces. It means you only have 2 seals. It means you only have 2 possibilities for leakage. It seemed like an intriguing way to go. Now, the other thing about thin glass is we looked at this a long time ago, like in 1990. We have a patent from 1990. Thin glass was almost impossible to find then. 5 or 10 years ago, it was possible to get, but it was expensive. It was on your cell phone, and it cost $5 or $10 a square foot. Now, courtesy of those flat screen TVs I'm showing you on the upper right there, it's available widely at relatively low cost. So this has become an option that looks sort of intriguing to us in terms of changing the sort of the playing field here in terms of what's possible. I'll throw out one other little sort of factoid here. There's about as much thin glass that goes into American homes each year in the form of televisions. We buy about 40 million televisions each year, which go into your homes, as window area that goes into homes. There's about 50 million windows that go into homes. So 50 million windows go into houses 40 million TVs go into houses. And these days, the TV is rapidly assuming the size of a typical window. Typical window is maybe 12 to 15 square feet. Typical TV is 7 to 8 square feet. So there's actually a lot of industrial experience with thin glass, just not in the window industry. Now, a few folks have.
Steve,
yeah.
just a quick, maybe 1 minute more to close up.
Okay, that's going to be tough, but I'll shoot through them quickly. Okay, so there are some products on the market now that use thin glass. Notice if you go to a quad, that's a R14 center glass. So actually, the closing slides, and so that was my end on the glazing. I just wanted to throw in a few more pitches for why we want better windows and why the industry should shift. And I'll try to do this in not much more than a minute. So comfort, this has been mentioned before. Triple glazing gives you ideal comfort in any glass area here from 25 to 100%. Notice if you go to double or double OE, portions of the room are going to be uncomfortable. This is a different way of looking at it. A version of this was shown this morning. If you're in Minnesota and you want to be comfortable as a function of glass area, if you are using triple, you can have glazing up to 75%. If you're using double, it's 15%. So there's a clear advantage there. If you want to dig into the details, into this in more detail, there's a nice calculator online, courtesy of Payette. This deals with radiant discomfort from the surface of the glass and draft discomfort from cold air falling off the glass. The other related piece here, which gets into cost, is if you're building, in a lot of cases, you'll see all glass facades with these radiant or these heaters at the base of the glass. This isn't so much to heat the space, it's to keep people comfortable near that cold glass area. If you go to triple, in most cases, you aren't going to need that. And the cost of going to triple in general should be less than the cost of putting in those radiant heating systems. The problem is you have to have confidence in this on the part of the engineer that that will really work. And if we talk about cost, aside from all the energy savings, the biggest cost by far in a building are people costs. And I think you've all heard versions of this, that the cost of occupancy in a building, this is at least a commercial building, is on the order of 100 times the cost of energy. There are some other interesting issues to explore in terms of the cost of floor area. Floor area today in an office building could be $200 to $500 a square foot. You often give it up by moving the desks away from the window in order to preserve comfort. You don't need to do that with the right solar control and the right insulating control. One other example, modern new codes, California's new code, they require new high performance walls, but they don't require anything more in the way of windows. But you can do trade-offs. And if you're a builder and you don't want to transition from 2x4 to 2x6 framing or exterior insulation, you can use triples instead. So we've seen a niche market here, possibly for better windows in California. So I want to close by talking about some groups that are pushing or working hard on this. I mentioned PAWS before, Partnership for Advanced Window Solutions. This is a group that's trying to change marketplace. It's not a technical group per se, but it's going to leverage and lean on organizations that are doing that. And I'll also throw in here for good luck that, I don't know if all of you know, that 2022 is the International Year of Glass, and their trademark is Glass Can Save the World. So I think we want to pile on and help explain how they can do that. One of the things PAWS will do is work with utilities to get incentives for better windows. So in the first year that you get new products in the market, they're typically more expensive. If we can help offset some of those costs, that's an option to do. And then finally, the last comment is that we have a lot of interest in the US in decarbonizing the grid, changing out all that gas heating to electric heat pumps. It's crazy to do that in all those single glazed and double glazed homes. We could save billions in both the heat pumps themselves cost, as well as the electric infrastructure that will have to back them up if we first did something about the envelope. And so this theme, of course, a lot of this is going to be existing buildings and retrofit. So I just want to throw in one more picture on the retrofit side, that although full window and facade replacement and retrofit would be great if it can be done and you can afford it, there are a lot of other things to do in the facade and glazing world here in terms of just replacing the glass rather than the whole window, interior and exterior add-ons, shading systems, and so on that we should be thinking about. So the final sort of sum here is that I think we can add more options to the portfolio that we have in terms of both Passive House and all other buildings by taking a careful look at what's out there now in building on that. And I sort of pitched this idea that maybe building on this Energy Star theme of getting better triple glazed windows out there is a way to go. We need to be proactive and aggressive in marketing and then innovating where that's needed. In some cases, I think I noted that we can get by using things we have now. In other cases, we have to do some innovation. And the other thing is that I think we need scalable solutions, not just one-off. And that's why looking at these standard product offerings is going to be so important. So
Thanks, Steve.
That's it.
Cool. Thank you. Appreciate it. We're going to take questions at the end, do a discussion then. So without further ado, I'll have Bronwyn share her screen and talk to us about some policy levers. So Bronwyn, over to you.
Thanks, Helen. And thanks, Steve. I think this was a good segue to how what I'm going to be covering today. I really want to look at a little brief history of where passive house windows have sort of come from in the US, where we are right now, and look at some opportunities that are really emerging that I would really like to daylight and see if we can perhaps replicate those policies to drive, exactly what you're talking about, shift the market in a couple of different ways. And I like to reference this tandem bicycle illustration because I feel this is exactly where the passive house community can help lead the way, and then have programs like Energy Star come behind with the sort of more mass market adoption, but without the pioneering efforts of folks actually breaking ground. Really, we've seen industry quite reluctant to be the guinea pig and to be the testing beds for products or for new programs. So with that, I start with some ancient history. This goes back to 2012, where here actually in the US, we had 3 window manufacturers certify, passive, and design specifically new window products, and then have them certified by the Passive House Institute. 2 of which, the Synergist one and the Cali Passive one, came here out of California. And full disclosure, I was the designer of the Cali Passive window on the bottom. The Synergist window and the Northwind window did actually make it into production. The Cali Passive window unfortunately did not. But it was a heady time, and there was innovation happening. And really, I like to use this as the baseline of where we started, to show that this is really possible. There is interest. And then take a look at, going to the Passive House database, look at where we are today. And I have to say, I've, gone back from working in the window industry back to my design practice. So I haven't really kept up with too many of the updates as closely. And I was very encouraged to see some growth in the last 10 years. And, not to get distracted, but I was also quite surprised to see Kazakhstan and Bhutan and Botswana also have passive house components. But if we stay focused here and look at what we're trying to discuss more specifically, our North American context, and we're seeing quite an interesting scatter of window manufacturers actually producing and selling passive house certified components here in North America. And if we delve into a little further into the database, out of the punched window openings from the US, we have 10 manufacturers certified out of a total of 363 global options. And just a shout out to those folks here on the call, from our folks in Colorado at Alpen, the Intus folks, De Koenig, Zola, Rangate, and Rehau. We, we salute you. This is pioneering work, and you should be given full credit for it. Then if we go to north of the border here, Canada, the Canadians are doing something interesting, and this is what we'll dig into a little further in my presentation here. But they have 18 punched opening windows being sold and manufactured in their region. And some of the leaders, Westec, Cascadia, Westcon, really the who's who, Enertech, Rousseau, and Inline are really pioneering some high performance products up there. And again, really encouraging to see this happening. And not only in the punch glazing market, but we're seeing spacers being added. This is also a fairly new evolution to have these specific components certified, and also a curtain wall. And we'll hear a little bit more about one of the manufacturers, the glass curtain wall, but really quite impressive to see a cold climate curtain wall system to the PHA plus efficiency class being manufactured. This is no mean feat. And then again, also very inspiring to see sliding glass doors also being certified to Passive House standard coming out of Canada. Cascadia and Westec, anybody who works in the industry knows that sliding components are always much harder to meet high performance. So seeing those actually being developed and manufactured here is a really great sign. And if we go back to that map of where things are happening, what I started to look at and what we're seeing generally in our policy work at the Passive House Network are emerging patterns. And right here is a very intriguing a phenomenon happening across the border here in British Columbia. And if we dig down and peel the onion back to see what's really behind this, because really we found very early on that manufacturers are not going to produce high performance components unless there's a market demand. And I think, Steve, you and I can agree on that. That's exactly how Energy Star has been driving the window market. And as I said, looking back into what was the driver that really allowed those windows to start to emerge and that cluster to be happening in British Columbia. And what I found was this BC government, the Energy Mines and Low Carbon Innovation Department out of the BC government funded a incentive program that specifically supported window manufacturers to develop and design new window products and to assist them in the testing, the design, testing, and certification of those new products. The program offered up to 80,000 Canadian dollars, and it provided a certification subsidy both for Energy Star to $25,000 and for Passive House through the Passive House Institute to $40,000. And this really was the catalyst that has started really creating that cluster of certified new innovative products coming out of British Columbia. And then part of that funding to the government, in addition to helping fund the subsidy, also actually funded that the Passive House Translator protocol that Daniel presented earlier. So this was a very cohesive policy that worked with the manufacturers and also helped create the technical tools for how to move things forward in the market. In addition to the manufacturer's incentive program, what was also happening, the context that this was moving forward in the market was City of Vancouver had taken the lead on really starting to highlight and initiate passive house building construction. So they had really consciously looked at how to remove barriers to passive house in the Vancouver metro area. They added incentives to increase passive house uptake, and they developed their own passive house pilot projects. So there's a city fire station, there are city buildings that are being developed to passive house. And simultaneously, or shortly thereafter actually, the BC Energy STEP code created a glide path that identified passive house as one of the end goals of their building, their baseline building code. And this, I would postulate, is one of the key metrics, the key policy goals and drivers that has to be put in place to support manufacturers and incentivize manufacturers to actually produce higher performance products and bring them to market. Because without the market driver, the manufacturers have no business case for developing and bringing those products to market. And as I mentioned at the beginning, we know they are available. We know it's possible. And I think Steve and Helen and everybody else in the US window manufacturing industry will tell you they exist here already. We just don't bring them to market in a comprehensive, cohesive way. So this sort of goes back to the policy work that we have been really focusing on at the Passive House Network. And I want to show, this is sort of the core distillation of what we have found in our research, was that for policies to really work effectively, they must include 3 core elements. And all 3 of these core elements have to exist simultaneously for the policy to be successful. And these are primarily have been training subsidies. So helping professionals to understand how to do passive house or high performance building or net zero, whichever your particular framework that you're aiming for is built around. But training, you have to have professionals who understand what the processes are, the metrics and the tools. The second is project subsidies. So this would replicate the subsidy program that the manufacturers were given. And the third one that is essential is this clear end goal. And that was provided and has been provided in British Columbia by the STEP code and by the city programs that are identifying passive house as not the current code requirement, but the end destination. And more reasons to be optimistic. I'm seeing this starting to emerge as an idea, as a policy structure in many different places. And the Passive House Network will publish our full policy report at our conference in June. And we'll present it again at the ACEEE summer study in August. But where I'm seeing really exciting things happening in the middle of the country here in Colorado, Xcel Energy is doing a structured program. It's not specific for windows, but it gives $37,500 in subsidy incentive for certified passive house buildings for the Marshall Fire rebuild in the central Colorado area outside of Boulder. And interestingly, Energy Star is also given some great incentives there was 17,500. So this is really starting to support my tandem theory that I'm been promoting here at the Passive House Network, to see how we use programs to work in tandem, and how Passive House can help transform and lead a market to where the larger base of practitioners and industry can come behind with confidence after products have been pioneered and really tested in the marketplace. And of course, I'm referencing that, I'm assuming that is being done by the Passive House community. And not only is that good policy structure, but the economics behind it are actually quite robust. This is a report that was issued by Vancouver Economy, the vancouvereconomic.com, looking at how fenestration products can really boost local economies. They saw that the potential for fenestration products to inject quite a significant boost in the local economy was enormous. So this, yeah, I've expanded the graphic here from their page. Just under 1.819 million Canadian dollars can be generated in the fenestration industry. So subsidizing high performance fenestration local production actually is a very good investment in a local economy that can pay back quite significantly. And I'm going to close with a slide that I developed a good 12 years ago on these edge connections. And Helen, it sort of corroborates what you were saying earlier in the session about the impact of a performance. It doesn't make a massive amount of difference. And what I'm looking at here, sorry, there's background noise. What I did here was I used the same window profile, and I calculated the outputs for the installed window for 4 different windows, all of exactly the same total square foot area. So all of them were 24.1 square foot total. This is the window that you most often see designed in residential punched openings. But if you modify it to be a fixed and an operable, or a just an operable, wider and slightly less taller, or if you make it narrower and much taller, or a little bit taller, the performance output of the U performance output actually improves as you go towards the simpler window design. And while the difference is not enormous, going from 0.115 as the worst performer to the best performance at 0.13, if you multiply this over a building, and you see that is where the impact starts to really become quite significant. And so my point here is, what we're trying to do in the Passive House community is start to look much more closely at these connections. The connection of the window to the building, the connection of the data to the energy model, and the connection of the policies to the model to the building. And I think this is where we have some great opportunities to really work together to really drive better outcomes and transform our market and our industry to actually create products available for everybody, better products available for everybody.
Great point there, Bronwyn. And you notice it was all in the design. It wasn't material selection. It was about reducing the frame, reducing the edge, increasing the center. So it's design first, which I think is one of the most important things we should bear in mind on where we should start as we're looking at the thermal performance.
But until you have the data about what makes the difference, you can't change the design in an informed way. So it's
right.
Chicken and egg.
Yeah, great. Well, thanks, Bronwyn. We'll come back to that shortly. So let's move over to Peter Dushensky. Really appreciate your time here. Peter is from Glass Curtain, and he's going to talk to us about innovation in curtain wall. So that helps us understand some of the issues and challenges with bringing new innovations into our market. So over to you, Peter.
Wonderful. Thank you. Thank you very much for the introduction. And yeah, it's a pleasure to be here with such a great panel. And I saw some familiar faces or some familiar names in the chat as well. You'll have to excuse that I wasn't able to make it here for the whole presentation, but I caught bits and pieces from some notes from earlier. I'm actually in Bucharest, Romania right now, but the time zone makes it so that it's about 11 o'clock here, so a little bit closer to bedtime. But yeah, hopefully we can chat quickly about our journey the last couple of years for designing and ultimately manufacturing and bringing to market the world's first passive house certified cold climate curtain wall system. That's a bit of a mouthful, but we will break that down a little bit here. And of course, the chart will be this chart will be familiar to most of us, if not all of us here. And what we can sort of highlight here, at the very least, is yes, we have a little bit of the thermal performance numbers in the sort of lower right-hand corner. But then just, where are the cold climate regions? And, what do cold climate regions demand that other parts of the world don't? So Glass Curtain as a curtain wall manufacturer, we've been around over a decade now. We had always had North America's highest thermally performing curtain wall system. And this was leveraging fiberglass technology, fiberglass framing, which fiberglass has been known for decades now in the residential window space, but was really unknown basically in the commercial glazing space, which is what we knew and what we had experience with. It's mostly an aluminum kind of world. And we look at the passive house certified systems, we see that it's still very much an aluminum based world as well. There are some sort of timber products as well, some PVC products even that are certified to the cool temperate climate. But being that we are actually from central Western Canada, the prairies, where it is very cold, it gets to be -40 Celsius or Fahrenheit, however, it's the same at that temperature. But it gets to be very cold, and we have unique demands for heating our buildings and for maintaining livable, open built environments. And the high performance facades in our part of the world are not really a nice to have. They're very much a need to have. And I know, as everyone says, it's a cliche at this point that necessity is the mother of invention, and that is very much true in our case. Well, government has been very important in BC, for example, in very clearly articulating a roadmap for manufacturers and for the marketplace, for developers and for consumers and builders to build to better performance levels. For us on the prairies, there was no sort of provincial mandate that we were going to build the highest performing building products in the world. We just got it in our crazy heads that this was an idea. How hard could it be? But as we will see here, it was not actually quite as easy. Quick example of some of the projects that we typically build. We typically build projects. So some of the one on the right here is from Northern Alberta. It's a First Nations project that we completed recently. On the left here is a project in Iqaluit and in the territory of Nunavut. And those of you who maybe haven't had a chance to travel to Canada's territories and to the far north, this is about a 3 or 4 hour flight due north of Toronto. So the distance between sort of where we are in Alberta to Toronto is about 4 hours, and so it's again about another similar stretch north of that, and it's on Baffin Island. So they get about minus 60 degrees Celsius in the winter. So again, buildings that are not very highly glazed. So to do even a 30% glazed building was quite something. So we thought, hey, we've got all the tricks in the book. We can make the highest thermally performing curtain wall on the planet. How hard could it be to certify to Passive House? I mean, Passive House has its roots even on the Canadian prairies, right? It sort of has its roots at the Saskatchewan Conservation House in many ways. So it's like, this is our backyard. Like, how hard could it be? What could have changed in the last few decades? So when we took our first crack with our standard ThermaFrame 7 system, which is, they're called ThermaFrame 7 because it's R7, we sent it to the Passive House, to Adrian, who I think I saw here on the call. He may remember way back in 2017. Hopefully we didn't convey too much sort of bravado at the time. We thought at the very least we could certify the cool temperate standard, which is 0.8 watts per meter squared Kelvin. Not quite. We weren't quite there. So we were actually at 0.93 watts per meter squared Kelvin at the time, with the fixed glazing of 0.7 watts per meter squared Kelvin. And sorry, I know there's a lot of talk about U values and BTU sort of imperial units, but the rest of this presentation will be in the sort of metric that. And of course, it's interesting to know. It's worthwhile noting that. While in Canada we use a mix of watts per meter squared Kelvin of imperial and metric, we still use NFRC in Canada, and that was a learning curve for us to figure out the EN 673 standard that the European systems are the German certification that Passive House is using are certified to. So that was a bit of a learning curve, but it's interesting to note that the projects that we've dealt on so far actually have this same challenge as well. These early projects that we've are consulting on and bidding on are just coming out to tender actually now in 2022. So while we planted the seeds for this in 2017, this is all just really coming to bear fruit now. But there is still a lot of, I won't say there. I would say there's even some still confusion, right, about which standard are we modeling to, which one is, which components are going to work for us. There's even some difficulty, when it comes to other parts of the facade assembly with things like doors. We're having some challenges actually right now finding the right kind of doors to fit to our curtain wall systems, because even things like panic bars, panic bars meet some. They're not. This is beyond the sort of scope of our thermal conversation here at the moment, but just to some of the practical realities, panic bars it has one American standard and another for European standard, and currently they're not talking to each other very well. But this is something that this is the early phases. It feels like of the Passive House movement in Canada in these cold climates, and we're seeing projects in BC. In Manitoba in the central part of the country, and then also into Ontario that are specifying. But yeah, our standard system that we would normally use, this is what it looked like when we did our initial preliminary models, attempting to go to cool temperate climate standard. And yeah, it just was not quite good enough. We're off by a good 15% or close to it. That was a bit of a wake-up call to us. But it was also a nice challenge, right? It sort of seemed like, oh well, maybe this is something we should actually, we actually need to go to the drawing board again and figure out how can we improve our system. What is it that these aluminum-based manufacturers are doing? How is it that we have this, fiberglass conducts at 200 times less than aluminum? How is it that we're leveraging this advanced material technology of fiberglass framing, and yet we still can't compete on, at least in our preliminary standings, with the Rycos and the Schucos and these other sort of aluminum curtain wall companies, mostly coming from Europe. And so it was, so it turns out we were able to sort of like, I wouldn't say totally reverse engineer what they were doing, but definitely learn a lot from the designs and see kind of the different level, the size of the gaskets were very different that they were using. They're much larger. They had these special air flaps to sort of break the airflow. in the nosing cavity. We also then recessed the aluminum because the aluminum was outboard for our screw chase for our fiberglass pressure plates and caps. So there's obviously been a lot of conversation here about residential windows, but commercial glazing for low-rise commercial is all site glazed, and so the framing comes knocked down to site. So you have a whole bunch of sticks that we assemble like Lego, and then the glass is then pressure sort of screwed into place with a pressure fit. And so the gaskets were very important. The location of the screw chase, the material of the screws. So we ended up using stainless steel screws instead of conventional steel screws. So all these little details, and we really came to appreciate just the level of detail that into the material science, into the chemistry that the Passive House Institute was looking at. And it was, an incredibly, it was sort of a moment of awe that this level of detail was being considered, because we knew that no one in the sort of conventional Canadian or North American industry was paying attention to this level of detail. And then when it came time to do our stretch goal was cold climate. We thought, hey, you know what? This is kind of crazy. We have this great material that's fiberglass. How is it that everyone else can do cold climate? Or cool temperate climate. No one in the world could do cold climate at that time. We thought, how is that possible? How is it that no one can do this? Maybe there's no market demand. Maybe there's the Finlands and the other sort of like northern Scandinavian countries, Denmark or what have you, weren't doing as much passive house. But we thought there's got to be a market there. Certainly there is in most of Canada, except for a little bit of the West Coast and Lower Mainland, and then a little bit around the Great Lakes region, which are, yes, the large population centers, but not in any way by square foot or by square kilometer, square mileage, the preponderance or majority of the country. So we figured there's got to be the way to do a cold climate, and sure enough, there was, but it was not a straightforward path, as Adrian, I'm sure, could attest. And it interestingly, it ultimately came out that we recessed the aluminum here. We had this EPS foam nosing, and the weakness actually became the glazing again. And so actually the edge seal of the glazing, and we had to find the secondary seal that was the best secondary seal in the world. Was the only way to get the glass to perform actually. And then also we had to increase these large the spacer. So to Stephen's point about how much difference that additional space makes. We only do triple glaze systems as a function of necessity of our climate in our part of the world, but also sort of from a principle perspective that we very much see triple as the future, and we like to be on the avant-garde. But instead of a standard triple glaze IGU is 1 3/4 inches thick, we had to actually increase those spaces to 19 mil spaces from 13 mil. So we ended up with 2 1/4 inch overall thick unit. So a much larger unit than is conventional. Doesn't make it any heavier per se. Makes minor adjustments are required for the engineering. The additional sort of asymmetric dead load there. But overall, it was just a matter of finding a way to make the model work. Interestingly, the European modeling software privileges those larger gaps more than NFRC software does. So that was a functional necessity for compliance with the Cold Climate Center, which we eventually did. And in late 2019, so yeah, about 2.5 years ago now, we were the first in the world to certify to cold climate with our stick-built ThermaFrame 9 pH system. It was formerly called 3rd pH plus. But yeah, it's quite interesting to see that we still don't have, to my knowledge, any other. maybe something changed since the last time I checked the database. But it still seems like we're the only ones in the world with this level of performance. So we get to run around saying that we have the highest thermally performing system, which is obviously, if nothing else, great marketing. And you can see here that is 0.6 watts per meter squared Kelvin overall, and the PHA plus, as you heard earlier. And so, hey, we certified, and this was with, to talk about the different kinds of government support. In BC, in the British Columbia, there's very clear government support for okay, this whole province, we're going to sort of go on this mission. We're going on this mission to passive house. And everybody, all the manufacturers can get there, all the home builders, all the The community centers will all be, any public project will all be, towards Passive House standard. We're all going to get there together. In Alberta, it's a little bit more of the sort of like, maybe Texas is the right kind of analogy. It's about gunslinging. So it's a little bit more sort of freedom oriented, what you might say. But the government has been super supportive to support us on our vision. So they're not going to tell us what the vision is, but they've been incredibly supportive to help us realize our vision. So they helped us with the certification, as well as the new die designs, because dies for fiberglass are very expensive. So they helped us to support that initiative, which made a huge difference, made a night and day difference, really fast tracked our adoption and our ability to make that investment by, we would probably be making that investment now. We'd probably start that in 2022. So, they saved us 3 years so that now when the market is today looking for specifying projects, I mean, we'll probably bid on maybe three. We'll probably bid on 3 cold climate passive house projects this year in Canada. Imagine if we were just starting to certify now, we actually wouldn't be production ready until 2025, because in these intervening years since 2019, we've then had to take this, and yes, it's one thing to model it, but it's another thing to get it to production. And so we had to do all this engineering, and with the support of, actually in Manitoba, there was another government agency. Unfortunately, it lost government funding, which is kind of crazy to think that just as there's all of this incredible innovation coming out of this, it was called the Composite Innovation Center in Manitoba. Just as it was coming out, unfortunately, they closed shop. We still have contacts with some of their former consultants and things, but we're not sure what the future of that space looks like. But yeah, we had to do all of the thermal analysis, the load analysis. The thermal analysis was done, but using fiberglass setting chairs and things for the first time. All of these things we used to make out of metal, we are making more out of composite. How to reinforce the shoulder and make it, so we had to technically make it work from an engineering and sort of mechanical perspective, I should say. We had the thermal figured out, a couple years ago, but to figure out the mechanical part took another probably year, and then only in the last couple of months we finally got all the production ready to go. There's obviously supply chain challenges with getting some of the basic materials that we needed, and even just getting the dies pultruded, just the dies cut, took a lot longer than it should have in normal times. But this is the world this is the pandemic world that trying to bring things to production in a pandemic time is never easy either. But we are production ready now. So we just finished our air water fire testing, fire testing is coming very soon as well. But the air water penetration, condensation testing, that kind of thing is all done for North America. That was just done a couple of months ago. And now it comes down to detailing. And this is where we are now working, because it's all very nice to have this component on the database and the Passive House database. But now we have to make sure that these are installed properly in Passive House projects. So we're now working very closely with several Passive House, several design teams across the country on their various projects to make sure that these systems are designed appropriately, and then of course to accommodate the various glass permutations and combinations that come up, because we certified to one glass, but of course as soon as you deviate from that a little bit, we have to remodel everything. So we've been taking on a lot of that extra work lately, which has been fun. And of course, fiberglass, one of the challenges of fiberglass is its quote unquote combustibility. Of course, aluminum will combust at a certain temperature as well, but fiberglass is not, despite the thermal breaks and everything that aluminum systems typically have these days with high performance products especially, fiberglass systems have to comply with an additional flame spread standard that aluminum systems do not. Yet currently, this is still, these codes will probably change in the next few years to make it so that we're all on a level playing field. But in the interim, we still want to be on the market. We still want to be competitive. So we just have to do these additional tests, which again, we're doing in Texas actually with Alberta Innovate Support and at Intertech. So we did the CAN-UL CS134 for our old system, and we're about to do in the next, in probably May, June this year, the CAN-ULC for the Passive House system, or our new framing system, I should say, as well as the NFPA 285, which is the US exterior flame spread. So that is the other piece of the puzzle for getting, taking something that's, from the drawing table all the way to site is quite the little process. But that is a little bit of our journey from for manufacturing the world's first passive house cold climate system. So thank you all very much.
That's great. Thank you, Peter. Really great insights into the development process. So now we're going to get into our discussion. So if maybe you stop your screen share, I'm going to bring Bronwyn back, Steve back, and we're going to have Adrian come back too, albeit for a short period, because I think he has to leave for this discussion. So that was really interesting. So really our topic here is about how do we shape the regulatory environment or the market environment to drive high performance fenestration. Now, whether it happens to be for passive house or for other through other certifications or performance requirements. So, you know, I've said many times we have high performance fenestration available in North America, maybe not to the level that Peter just talked about, but even to that level, we're not using it, right? We're still back in where the technology was 20 some years ago, and we're not even using more up-to-date technology. So I'd really like to get everyone's individual thoughts on, from your particular perspective, what are the current barriers to high performance fenestration that you're seeing? What are the major barriers? And maybe I'll start with you, Bronwyn.
So I'd say the first one is just the simple transparency of what actual windows, you know, how they impact building performance from the very simple like inputs on the model. I mean, right now, we literally, you know, our code doesn't give us that. So designers like myself who are interested in this will not get it from a code framework. So we can't make informed decisions about our design impacts. And I think right there, that's the biggest barrier. And fortunately, the easiest one to actually remove.
Right.
In theory.
Yeah, in theory, right? So Peter, in your perspective, because you probably have a unique perspective as a manufacturer, what do you think the barriers are to actually getting high performance fenestration in the market?
Yeah, I mean, I would say that there's another room for government as well, beyond just policy, and that's leading by example. And that's definitely what we mostly do institutional work for, kind of that reason, is that, you know, the more progressive jurisdictions, municipalities, levels of government that are looking to make a sort of values-driven statement, you know, when they have that opportunity to do so, I think it's, you know, it behooves them to do so. Like it's their you know, it's their fight to lose in a way as sort of as market leaders. And I think that they can, you know, in doing so, by also selecting manufacturers that you know, are local manufacturers as well. Those are, you know, by supporting domestic manufacturing wherever domestic may be, it encourages that, you know, encourages the marketplace to want to be part of those showcase projects. And those showcase projects have a funny way of rippling. All of these things take time, but, you know, you drop a pebble in the pond, eventually, you know, the ripples will get everywhere. And that's what I would say.
Great, thanks. Steve, from your perspective, and you've got a really nice multi-decade kind of view back over what has been the barriers to several technology adoptions.
Yeah, I mean, one of the obvious ones is cost. We live in an environment where least cost, at least in some frame of reference, least cost is always the thing that people think about most. It's not always the case, of course, but it is frequently with buildings. And value engineering is that horrible term that drops out good stuff that might have been put in at the beginning. And you know, cost is related. There's the hard cost of stuff, and then there's the cost as perceived or experienced by people. And I think That's a supply chain issue. There's a bunch of issues there. In the last year or so, people have sort of begun to understand rather, what those issues really are. If, you know, to the extent that the higher performing products are special order almost always adds time, cost, and risk to something. Take the identical product and make it standard, and everything gets simpler. That's why I kind of beat up on this idea of, if we can make something more like Energy Star and make it standard and make it, you know, a typical product that everyone specs, then some of these barriers go away. But you don't get there automatically. You need to get there through a pathway. And I think we've all been talking about the obstacles along the way. But I think demonstration, I mean, the idea of demonstration projects to prove things out, subsidies at the right time in the right place. Subsidies can be dangerous, I would say, if they artificially elevate a product, and when the subsidy is removed, the product crashes. Ideally, the subsidy is there until the point where multiple players get in and offer it at lower cost, and then you don't need the subsidy. So they're great to start off. Anything that reduces risk on the financial side as well as the technical side is good. Demonstration, GSA does a variety of a program called Green Proving Ground that I hope a lot of you know about. They put technology that's on the market but not mainstream into their own buildings, and then hire a national lab or someone to write an objective report about how it worked. And you know that they aren't always slam dunk, oh, it was wonderful. They point out the flaws and the challenges and the issues as well. And then I go back to Bronwyn's comment about tools, and you know, if something doesn't get past the design team, the architect or the engineer, unless you get an extraordinary owner who says, I don't care what you guys say, I want that product. And of course that happens occasionally. But if the architect and engineer don't have the confidence, don't know how to model it, don't understand aspects of it, it's just not going to make it into the real world. So whole bunch of issues there that need to be dealt with.
I know, Adrian, you're probably coming from a European perspective, but it would be interesting to know, again, looking back into the history of high performance fenestration development and adoption in the European market, what were the barriers there and how were they overcome?
But the actual development of these components, they were not driven by the big players in the industry, right? So it started with the small carpenters and people daring to take a risk. Right now it's a little bit complicated, and I totally agree to what Stephen said. Not only supply chain, but also raw materials being like doubled or tripled up within a year. And on the other hand, we're facing the next energy crisis here in Europe. So the standard products are sold out. And you know, everything which gives you certain plus is out of the, you know, regular prices. Yeah, these things, there are always phases like that, right? So that was the same when I started doing that after the financial crisis. It was comparable. So nobody wanted to build passive house components. There was no need for that. But I think these are the times where you have to put the where you have to make the innovation and to be prepared for the times when the world is better again, right? Yeah.
Makes sense. You know, it's interesting because now there are some barriers to maybe adopting passive house. There's also barriers to adopting high performance fenestration outside of passive house too. And some of the things that come to mind that haven't been mentioned are obviously our baseline codes. They don't really support high performance fenestration. I mean, typically builders will build to the code. I don't hear, there are some maybe institutional, as you talked about, Peter, clients that will build above code, but the majority are building at code. In my experience, I've come across I'm not going to adopt a new technology unless I have 3 equivalents, right? I need to see a 10-year track record, and I got to have 3 equivalents in my project. So I'm sure, Peter, you've come across this kind of thing too, that slows down technology adoption because you've got to wait for everybody else to catch up, or you've got to wait for those innovators to, as Adrian, you said, you know, take a risk, small players take a risk, and then wait for that track record to develop. And that is a very long time in our architectural cycle. So it's kind of interesting. And the other thing I was interested about is, and I'm talking more in the mainstream of the rinse and repeat specifications. It worked last time on my building. I'm going to do the same thing again. Do you guys see that a lot? Is that a so I guess I would ask, if we're looking at trying to change the policy landscape, we heard from Bronwyn lots of stuff, good stuff that's happening in up in Vancouver and British Columbia. We need some sticks and we need some carrots, right, to make make the laggards do better and incent the forward thinking. So what do you think individually from your experience are the things, the carrots and sticks that work the best, that you would, if you had your magic wand, that you would implement, and why do you think that? And Bronwyn, I'll hand it to you because I think you have some good insights on this.
Sure, thanks, Helen. So I think, you know, we've looked at quite extensively and in quite significant detail this carrot stick conundrum in policies, and seeing how we can drive better buildings, better products forward. And what I'm seeing are these patterns that are emerging, and the carrots are really where you get the innovation. The sticks are for the back end of the market. You know, the sticks, what, you know, and we actually put an excessive amount of money towards that back end of the market, and we put very little money to the front end of the market. And you know, that sort of intrigues me to see. And this is where that BC innovation funding, the incentive funding came forward. It's the carrot funding for the manufacturers that I haven't seen here in the same structure. So put more carrots to where we want the market to go. But what I'm also seeing, there were some other things that are really important to why that's actually working. And the first one was that it was available to multiple manufacturers, and multiple manufacturers actually went for it. Because when you get one manufacturer doing something in isolation, that doesn't move the market, because it's sort of this herd, you know, safety and numbers quality that has to actually exist for everybody to really like feel comfortable to move things forward. And I didn't talk about a funding that was done by NRCan previous to that BC program, where they literally gave $1 million to one manufacturer to develop a passive house product. And it literally took 10 years for that manufacturer to actually finally certify. And I'm not going to name names, but it was because they just gave all the money to one manufacturer. It was a total dead loss. I mean, not total dead loss, as they finally did get a profile certified. But it's the herd, so you have to have the safety and numbers, and then you have to have the carrot in place in the market that gives the manufacturers the incentive to actually develop something. And that was done by the BC Step Code and by the City of Vancouver incentives that said our REACH code is going to end up in passive house. And it's still, you know, that BC Step Code has gone through a bunch of different iterations, but it clearly identified an end goal. And then manufacturers are going to say, okay, well, we can incrementally improve our product every 3 years or 5 years, or we can just go straight to the end goal. And that's what they did. And I think that's really the carrot, you know, you know, this carrot stick business. There's so many sticks. That's what baseline code is for. The baseline code is for the back end of the market. It's not for the front end. And if we want a front end, we have to fund it and we have to support it.
Fine. Peter, what's your perspective on that as a manufacturer? What are the carrots and or sticks that you would like to see to drive your business?
Yeah, I think Bronwyn touched on really the key ones, and I think yeah, I would say something like an energy step code, like a VC energy step code, was so valuable, even though we're not in VC. I mean, it was just so we could just see it happening. We could see it happening in real time. How much visibility, how important. I mean, most of these developers are thinking in 5 and 10 year increments plus, right? You have to be, right? Real estate's a very long game. Sometimes you're thinking in 20 years and 30 year, increments. And it just provides so much clarity to the industry to say, here's where we're going to be, here's where we are today, here's what we'll be in 3 years, here's what we'll be in 6 years, here's what we'll be in 9 years, here's what we'll be in 20 years, right? And that just felt very reassuring, I think, for the whole construction community. They had, they did great like outreach and support, like, these little meetings and webinars, and here's how to make it all happen. I think that was great. I might just touch on quickly Helen's earlier point about, other manufacturers having, comparables, on spec sheets and things. This is why we are very big fans of the German manufacturers, actually. So the German manufacturers provide us a lot of validation, and to say, yes, you can absolutely specify. Here's a performance specification. Here's your competitors. For Canadians, German stuff is just cool, right? Your Mercedes, your Porsche, it's like, high performance, high, fast, zippy stuff. It's cool, right? So it's like, yeah, you can import it. But, we have big advantages in terms of distribution. We have big advantages in terms of price, I would think, as well. And in terms of, we have a lot of marketplace advantages compared to someone who's trying to, supply chain these days, right? If there's not enough, curtain wall in aluminum in Germany, there's definitely not enough to bring over to Canada to come compete in some, little, project in Yellowknife or in the territories or something so I think that we really appreciate having, sort of broadening, I think, what the herd is, like the ability to just broaden, those are kinds of carrots. Like if we can sort of broaden our lens of who are our competitors, right? If we say our competitors are not just, who are we on par with? It's like, if we want to be the Tesla or whatever, right? We want to be on par with the best in the world. We don't just want to be, see ourselves as equal of, oh, well, Joe down the street who makes, double glazed Conair, he's not our competitor, right? We have to see ourselves as part of a larger context. And that's, that kind of feels like the carrot and the stick. I think the best stick that I've seen anyways are these regional, these regional long-term visions for energy performance.
Cool. Steve, do you want to take a go at the sticks and carrots question?
Sure. I mean, there's a bunch of different ones that you can apply. One of the ways of looking at this is this old concept of sort of the valley of death, going from R&D to market, and there's a bunch of different places along where you can die, right? If you're doing basic R&D and you have something that looks good, you may need resources of various sorts to get the R&D to proof of concept. But even if you got a proof of concept, you have a prototype that works, then there's stuff like a pilot line. And then if you can make, like in the case of glazing, we often see people at the university level show me a 1-inch square of a smart glass or something. Isn't it great? And they think, well, if you make it work at 1-inch square, well, sure, it can be scaled to a couple of meters easily. But there's a couple of steps along the way there. And frankly, the landscape is littered with companies that have done really well at the front end and haven't made it. There are a bunch of different government programs, both federal and state, that try to intervene at different places, intervene at basic R&D. There was a program, an ARPA-E program a while back called, I think it's called SHIELD. It was trying to get a single glaze retrofit. Could you come up with a piece of something that you could apply to single glazing and make it like R3 or 5? And, and that program explicitly was high risk. They funded 20 or 25 companies and they hoped that one of them might work. But if even one worked, you had great, great payoffs. I'm not quite sure whether it is. A couple of them have come out the end, and I haven't seen any products yet. But so I think spending a little more time thinking about where the pitfalls and where the holes and where the risks are, and then trying to intervene at those places. And it may be different for a curtain wall than a window, for an IGU, for a tool. I mean, we haven't talked. A few people have mentioned, software that works. Therm came up a bunch of times today. DOE has paid LBL over the years to improve the tool when the users come back and say, hey, I wish it would do this, or can't it do that? In general, DOE has funded that to keep going. There are private tools that do some of that as well. So I think there's a whole portfolio of activities out there. I think the challenging ones are towards the end, when you've got a prototype and maybe even have a pilot plant, and then how do you get from there to a manufactured product that can be made at scale at a reasonable cost? And the cost is another issue too, right? If you make a small volume, typically the costs are high. If the costs are high, people don't want it. So getting past that is an issue. Now, the thing that guarantees volume, of course, are the code. But as we've talked, Helen, a lot, the problem with the code is if you invert that, the code mandates that it be cost effective. Otherwise, it won't become part of the code. And if it was cost effective, then it was already out there in volume. So it doesn't solve the problem. I think what Bronwyn talked about the step codes and about the reach codes, that's maybe a way to navigate through that passage. But I think it's still a challenge. It's not going to be easy.
Yeah, I mean, we basically need to turn what's a vicious cycle of can't get the cost effectiveness right into a virtuous cycle of being able to drive cost effectiveness. And I think that's the challenge. How do you get from the vicious cycle to the virtuous cycle?
Yeah.
And bridge that gap. And Adrian, maybe you have some thoughts from the European perspective. How do you get, have you had some experience in Europe where you've got to that virtuous cycle of driving technology to cost effectiveness, or maybe it's just mandated and cost effectiveness isn't an issue?
Well, first of all, these saying carrots and sticks, I think in Germany we got the same saying. It's called sugar bread and whip. So I don't know why, but this is what we call it. And now Peter mentioned, some cool stuff from Germany or something. I think that former Chancellor Merkel was once asked what Germany is famous for, and she said it's airtight windows, right? So I think that's kind of maybe typical. It's not really cool, right? So I think first of all, we have the step from the code to passive house is very small right now, right? So the standard products are really close to passive house level right now. We have a lot of cities where passive house level is mandatory. So that creates a certain demand. But when we spin back the wheel of time, right, then we had a lot of successful manufacturers which were trying to create multiples. And that by combining different companies and different know-how, we had some participants right today. I have seen Chris Chan, for example, right? Companies that are really good in something, for example, doing the tools, and they have the engineering, but they need some, smaller companies that start producing them maybe on a smaller range, and then they can, resell the engineering, and that can be a good start. And sometimes I think when you're new to a market, you have to come up with also a business plan to compete. Also, I think I've seen it in the chat. That's a true fact. When I look at the, I know them too, sure. They are also our clients. The companies from Poland, or that have they can produce high quality products for a very low price because they do it since 30 years or something. They get the tools, they get the engineering. And now if you're trying to compete with a vinyl producer and start from scratch, well, you cannot really compete, right? It's kind of impossible. So you need to find a niche where to be there. But I think the market is really incredibly huge. So there's also like, there are always opportunities, especially for niche products, right? Or if you have a certain benefit or certain design, right? Somebody's maybe looking for fiberglass components. The other ones would like to have preferred timber frames, and the next one likes to have a pressure plate from aluminum. So I think, yeah, there are a lot of possibilities, and it's a huge market, I guess. And I think right now we have just 5% of the whole building industry market is, you know, passive house products, right? So I think there's still a huge chance to get into that.
And Adrian, I want to be respectful of your time because I think you have to leave. So when you need to go, please feel free, and I appreciate your.
It's 11 p.m. here, right? So I need to catch my last train.
Yes,
so,
can't miss that. We appreciate your perspective on the European dynamic. That's sometimes it's really good to learn from that, to see what worked and what could work here in North America. So I do have lots of other questions that I want to ask about the codes and standards, but I did notice there was a question from the audience about motorized exterior shading, and they want us to talk a little bit about the value of motorized exterior shading in combination with passive house windows. In the comment, was it so important, and the resources for it in North America are worse than the windows. So Bronwyn, do you want to take that one? And then I'll pass it over to Steve, because Steve understands exterior shading, dynamic shading, and glazing.
Sure. So I think, I think the comment is really germane. We are in a global warming crisis. Our building overheating is really critical. And this is not a passive house problem. It's a universal, everybody in the building problem. So exterior shading is something that we should be really focusing on. It comes back to that transparency of what actually gets calculated in the codes. We don't require overheating calculations in our standard code compliance models. We don't require, and there's limited shading inputs that actually occur in the standard code compliance models. And then the industry, the practitioners, the architects, and the engineers like myself literally don't get that information made apparent and transparent to us in our designs. So until we start daylighting that information and actually translating and transmitting the impact that has on the buildings, we won't actually start to get those products in the market. And it's the chicken and the egg thing. It goes back to that conversation about thermal bridging. Why would anybody calculate thermal bridging if they're not required to? Why would anybody learn? It just would be, like folks like myself who are very sort of driven to understand those things, and I'm more sort of motivated, self-motivated to actually go down those rabbit holes. Shading is key, and we've got the manufacturers here. They sell their products, their shading products in the European market, but they don't distribute them here, and that I find endlessly frustrating and annoying. That in California, the Hunter Douglas huge company sells exterior shading products in the European market, but I cannot buy it for my California projects. So again, transparency, until we start actually including this information in the just basic information and making it available to designers and practitioners, we won't get the product on the market, because why would manufacturers distribute something that there's no demand for it, because we literally can't see the impact of it at the building design level.
Steve, do you want to take this? Because I know you're involved in the attachment rating group, and also you've spent many years looking at dynamic integrated facades.
Yeah, you can. I think it's a really a seriously important challenge. You can slice and dice it a variety of different ways. I mean, one thing is interior versus exterior. Interior stuff normally means the shades and blinds that aren't spec'd by the architect, but are chosen by the, well, if it's a house anyway, chosen by the homeowners. Done well, I mean, they can work fairly well, but in general, people don't use them. I mean, they leave them open, they leave them closed. They're decorative as opposed to functional. And clearly from a solar heat gain point of view, it's far better to have it outside. But now you're back to the just the way Europeans worked, which is they didn't normally have AC, so they needed shading to keep themselves cool. We build all of our houses with air conditioning in them, so we don't need shading, right? Because the AC takes care of it. So there's a vicious cycle there that one needs to get through. And then I think the integration issue, I mean, if you have, there's two flavors of exterior shading, right? There's the fixed stuff, there's overhangs and fins that if you're an architect and you know sun angles and you have a nice tool, you can do a decent job of keeping the sun out at the worst times. But remember that March and September are the same from a solar point of view. March typically is winter and you'd like the sun. September is, around here anyway, it's the peak of fire season and cooling, and you don't want the sun. So there are limits to anything that's fixed. If you go to automated shading, you have all the problems Bronwyn talked about yeah, the hardware in theory is available, or on, you know, in a catalog is available, but can I buy it from the local rep? But the bigger issue, I think, is one, even if you get to buy it and install it, can it be operated properly? Is it going to be integrated into, is it manual or automated? If it's manual and people do the right thing, that's probably good. If it's, I think you'd like it to be automated, because if you're not at home and you know there's a solar issue, then you'd like it to do the right thing automatically. I mean, after all, we have thermostats that turn the heat on at the right time, so that shouldn't be rocket science. But now you've got a whole new set of sensors and controls and protocols and you know, things that aren't interoperable. I think in Europe there's enough critical mass. There's the European Solar Shading Organization that get all the players together and they standardize stuff as much as possible. So if you spec it from company A or company B, probably you'll get the right thing and probably it will work. In the US, I think it's a crapshoot at this point, which isn't to say that there isn't some good stuff out there, but whether you can get it installed, get it to work right. I find that particularly frustrating since we live at a time and a place where we're talking about autonomous cars. You know, we have the smarts to put sensors and controls and AI together to take a car speeding down the street and make split-second decisions about life and death, and we have confidence that can work. But if you go to an architect or an engineer and say, well, let's put an automated shading and then let's cut the size of the cooling system, they'll say, but wait a minute, what if the automated shading doesn't work? How do we know it's going to work? You know, and it's a fair question because it probably frequently doesn't, but there's no reason why it shouldn't in terms of the technology available. And exactly how to overcome all that. You know, the one other thing didn't come up before I was going to mention, maybe it's applicable here, is tax credits to subsidize the cost. And that's relevant because at the moment there's a push to get a tax credit for smart glass. And we're talking about shading, but smart glass fits into that category too, right? Glass that changes optical properties automatically. And so there's a push to get a 30% tax credit through Congress for smart glass, which will be interesting to see. I mean, that's a political issue as much as a technical issue, but we'll see if that comes out the other end or not. But that could be a foot in the door to push this whole thing forward.
Which is ironic, Steve. I'm all for smart glass, and we've got this big push for smart buildings, and yet we can't get the basics right, which is just exterior passive shading. And I think this is a huge part of why we're hosting these symposia. We have a whole series of them on different product manufacturing because we're still not doing the basics right. And you and I, Steve, we live in the Bay Area. We live in the land of this. We live, literally most of my clients are tech engineers, and I'm literally putting third world products into their homes. They're developing the smartest technology and on the software side, but on our the actual buildings that they live and work in are are unfortunately, decades behind what's actually really available. And I think this is where we really have to start pushing the market and shaking up some of these systems that just are lagging woefully behind. And I think it comes back to that transparency. Until we actually know what's impacting things at the design level and educate our practitioners and our industry, nobody's going to make different choices. So I don't know.
That is just a great way to end our discussion. That was a great summary of kind of where we're at. And so hopefully this has been a good dive into the policy arena, understanding where the challenges are, where the opportunities are, to see if we can move the needle. We could have gone on for another hour, had lots of questions to ask, but we're hitting time. Maybe there's another time for us to continue. We haven't finished, and we'll put a pin in this, to be continued.